evaluating the limit at x equals to positive or negative infinity, which is the end behavior of the graph of the function. If the function is a rational expression or rational function, where the numerator and the denominators are both polynomials, then the trick is to divide by the largest power in the denominator. The largest power in the denominator. For part A, the limit at x equals to infinity of 3x squared plus 10x minus 1 over 2x squared minus 5x. We see that the largest power in the denominator is x squared, and so we would divide it by x squared to every single term. Essentially, what we are doing is to divide by x squared both on top and bottom. This is the golden rule. Whatever we do in the numerator, we would do the same thing in the denominator. But this method only works if x goes to infinity or negative infinity, which is the end behavior. Then we simplified. We will still need to rewrite the limit notation. 3x squared over x squared is 3 plus 10x over x squared is 10 over x minus 1 over x squared. But that is only the numerator. In the denominator, 2x squared over x squared is 2 minus 5x over x squared is 5 over x. Now, at x goes to infinity, then x squared also goes to infinity. In other words, as x gets arbitrarily large, x squared is also getting very large, but 1 over a very large number is almost 0. In terms of the limit, 10 over a very large number is almost 0, and 5 over a very large number is almost 0. We can say that because of this limit notation here. This is why we need to keep writing this limit at this step. Without this limit notation telling us that x is getting to a very large number, we will not be able to do this. What we end up with is 3 over 2. At this step, we no longer need to rewrite the limit because x is no longer in the expression. For part B, the limit at x goes to negative infinity of 10x squared plus 300x plus 1 over 5x plus 2. In the denominator, the largest power of x is 1, and so we would take every single term and divide it by x only. What we are doing is, again, we divide it by x both on top and bottom, and then simplifying. Keep in mind that again, we will need to keep rewriting the limit notation here. 10x squared over x is 10x. 300x over x is 300. 1 over x is still 1 over x. Over 5x over x is 5 plus 2 over x. At x goes to infinity, negative 1 over a very large negative number is 0. 2 over a very large negative number is almost 0. And so what we end up with is the limit at x goes to negative infinity of 10x plus 300 over 5. Again, we will still need to rewrite the limit notation because there is a term with x in the expression. Now, at x get to a very large negative number, then 10 times a very large negative number is still a very large negative number. And then we add 300 to that very large negative number would not do anything. And so we end up with a very large negative number divided by 5, which is still a very large negative number. And so the answer is negative infinity. Every time we write the infinity symbol, what we're saying is that the limit does not exist, but it does not exist in a special way. In this case, at x goes to the left, all the way to the left, the function decreases without bound. For part C, the limit at x goes to negative infinity of 2x to the fourth plus 20x cubed over 1000x to the fifth plus 6. We observe the denominator and see that the largest power in the denominator is x to the fifth. And so we will take every single term and divide it by x to the fifth, both the top and the bottom. And again, we can only do this if x goes to positive or negative infinity. Keep rewriting the limit notation. X goes to negative infinity. We simplify each of the terms. 2x to the fourth over x to the fifth is 2 over x. 20x cubed over x to the fifth is 20 over x squared. 1000x to the fifth over x to the fifth is 1000. And then 6 over x to the fifth. At x goes to negative infinity, 20 over a very large number is 0. 6 over a very large number is 0. And 2 over a very large number is 0. And so we end up with 0 over 1000, which is 0. The limit is 0 in this case.